right, so today's operation is division, but we're going to be using synthetic division. Synthetic division is a trick, and the key with synthetic division is it only works when you are dividing by a linear polynomial. So if you're not dividing by a linear polynomial, synthetic division is not going to work. So I couldn't be dividing by x squared here. Synthetic division, the way it works is you take the factor and you find out what solution that is. So x plus 4 equals 0, we move the 4 over, and x is equal to a negative 4. You take the solution and that's going to go outside. We're going to set up this box. And when we set up the box, we're going to write the coefficients of the equation we're dividing into. Now, we've got to be careful here because every degree, every exponent needs a place. So when I look here, I have an x squared, but I don't have my x term. So when I do that in my table, I need to make sure that I give a 1, a 0, and a 10. That missing x coefficient needs its place here. When we synthetically divide, we bring down the leading term, so 1. Then I multiply, so a negative 4 times 1 makes that a negative 4. And then I add 0 plus a negative 4, negative 4. Then I multiply. Negative 4 times negative 4 is a positive 16. 10 plus 16 is 26. Now we had an x squared and we divided out 1 degree. So 1 degree below x squared is x. These numbers that we created here are the coefficients of my new polynomial. So again, x squared, if I take 1 degree away, this means this is my x coefficient. This is my constant. And this right here is my remainder. When you write your remainder, we do plus. You take your remainder and you put it over your divisor. So when I divided my polynomials, that is what I am left with. X minus 4 plus 26 all over x plus 4. Now we use synthetic division to help us factor and solve polynomials. Now we know a lot of different ways to factor polynomials. Even though we have all of our old school and all of our new school rules, they're not all going to work and sometimes we get stuck. So we need to use synthetic division to help us. So again, if I'm looking at this, if I have 4 terms, the only way that we know how to factor given 4 terms is to factor by grouping. But if I go to group this, I pull out my x squared, that's 3x plus 13. I pull out my 2, that's x minus 4. Look at that, those aren't the same. That means it's not factorable. And when it's not factorable, we have to have another way to solve. And the way we do that is we use our synthetic division. Up here, I was told what I was dividing by. What we want to do is we want to factor out our solutions. So when we're not given a solution, we look at our calculator to find one. So we go to our calculator, we go to our y equals, we clear out what we have in there, 3x to the 3rd power plus 13x squared plus 2x minus 8. We're going to start off with a standard window, zoom 6. Now I need to change it a little bit. I need to move it up here. So I go to my window because I want to be able to see that whole thing. I hit graph. Oh, I didn't move it far enough. Let me change it to 30. So what I need to do is I need to look at my graph and I need to find a solution. And I'm going to be guessing here. So I'm looking for an x-intercept. I'm just going to pick this first one right here. And it looks like at 1, 2, 3, 4. It looks like at a negative 4. So I'm going to guess that it's a negative 4. So remember, synthetic division, we put our solution out here. And then inside we're going to put those coefficients. I checked my degrees, 3, 2, 1, 0. Those coefficients there are 3, 13, 2, and a negative 8. I'm going to sketch my graph over here. So remember what I've got. Okay, we bring down that first term of a 3. We multiply negative 4 times 3. That's a negative 12. And then we add 13 minus 12. That's 1. We multiply negative 4 times 1. Negative 4. We add vertically 2 minus 4. Negative 2. And then we multiply negative 4 times negative 2. A positive 8. Notice how it's a 0. When we have a remainder of 0, that means it's a solution. And that's what we were looking for, we were hoping. So that tells us that we have a solution there at negative 4. That's good. That's what we wanted. So we need to continue to factor, because remember, we want to get our equation in factored form. We're expecting to find 3 total solutions. Now we started with a cubic function and we factored out 1 solution. That means I'm now at x squared. Remember, cubic, 1 degree lower is squared. So this becomes 3x squared plus x minus 2. Remember, there's no remainder. We are now down to a quadratic, and we know all of our quadratic methods of factoring. This one is going to be Batman. Multiply the first and the last. Bring down the first. Bring down the last. We break that apart. We're multiplying to a negative 6 and adding to a positive 1. So that's going to be a positive 3x and a negative 2x. We pull out those GCFs, 3x, which is x plus 1. Pull out the negative 2, that's x plus 1. So this is going to give us 3x minus 2 and x plus 1. Oops. Okay, so now we have what we need. We're going to write our equation in factored form. When we factored, we found that 3x minus 2, the x plus 1, and then remember, we had a solution here at negative 4. If I have a solution of negative 4, that means I have a factor at x plus 4. Because remember, the factor is what you started with that gave you that solution, so we just move that 4 over. This is our polynomial in factored form. That allows us to find all of our solutions. 3x minus 2 equals 0. We move that 2 over and we get x equals 2/3. X is equal to a negative 1 and x is equal to a negative 4. And we're lucky here. We had 3 real solutions. So this is going to be at 2/3, 0, and this is at a negative 1, 0. As I was looking at my graph, I could have chosen a negative 4 to start with. I could have also chosen a negative 1. I would not have chosen this last one because as we found out it was 2/3. You only want to pick ones that look like they're exact points. You don't want to pick anything that looks like it's going to be a decimal. So we chose a negative 4. Just know that you also could have chosen the negative 1, but these numbers would have been different and then your factoring would have been different. So then when you factor down here, it would have been 3x minus 2 and x plus 4 inside of your Batman. So it's kind of like when we did Batman to begin with. It doesn't matter if I put the 3x first or the negative 2x first. In the end, it all works itself out. Okay, that is your synthetic division.